Hi, we are Team Trosha and we'll be working on non-invasive, on-the-go, low-cost and scalable methods for diagnostic anemia for an on-the-go. We know that anemia is a prevalent disease or symptomatic condition which is prevalent worldwide. So for this problem, we have decided to use the photocaustic phenomena. In photocaustic phenomena, a pulse laser light is focused on a tissue which will get a thermoelastic expansion which will result in an acoustic wave formation, and this acoustic wave formation can be detected by ultrasonic detector and image can be formed. So what we'll get? We'll get absorption coefficient of a blood, but we see that we'll get absorption coefficient of oxygenated and deoxygenated blood. But for this reason, we are using a radial artery. The reason for radial artery is it is an artery, so that maximum amount of blood is oxygenated, so we can remove the factor of deoxygenated blood. Second thing is it is a 3 mm below the skin and easily palpable. So detection of a radial artery is not a difficult task. So with this, we are removing a deoxygenated part. So what we are getting in a graph is optometric acoustic signal with time. We are getting this signal, and acoustic signal amplitude, we are getting a near linear scale. So we can say that we can get to an exacting amount of hemoglobin concentration of a blood by detecting this area. Reference can be seen. So this will be a block diagram where we are seeing the tunable pulse laser is thrown on an area of a tissue which is getting a thermal expansion, which is creating ultrasonic signal which is being received and signal is processing and then is displayed on a board. But by this we are getting a concentration of hemoglobin. But how to characterize anemia, whether it is megaloblastic or microcytic, because size of RBCs also matter. So we can do this by photocaustic spectrum analysis. Here in this graph we can say that peak of the spectrum analysis is indicating the size of the RBC. If higher the peak, it says the RBC size is bigger. If lower the peak, it says the RBC size is smaller. So we can normalize with the condition so that above the normal size of the RBC can be considered as megaloblastic, and below the normal size of the RBC can be considered as a microcytic. So like that we can differentiate among megaloblastic and microcytic anemia, which is the most common cause of anemia. So we can see reference point is also given here. So by this we can get a non-invasive device, but market strategy we have to see that cost should also be effective. The prototype which we are making is approximately costing 2090. That is made 2100. So we can see that it is an easy on-the-go device and also cost-effective, which can be easily used for a survey purpose, because we cannot say that it is highly accurate, but we can diagnose or segregate the population of girls with a high amount of accuracy so that we can lead them for a further tertiary investigation for accurate determination of anemia. So we are thanking